In this tutorial, we will be covering how to complete the net efficiency calculations for homework 5. So you'll go in and download your net efficiency data from Lyle Courses, and we're going to start by calculating RAR. So RAR is VCO2 divided by VO2. Make sure you do them in the right order. And then to calculate caloric equivalent, we're doing 1.1 times our RAR plus 3.9. And then now, instead of multiplying by 5, like we typically do, we're going to multiply by our caloric equivalent. So 4.93 multiplied by our VO2. Make sure your VO2 is in liters per minute. If not, you'll need to go in and do that step as well. And then we can just easily drag this across, Control C, and paste everywhere in each section, because in each section we need to complete RAR, caloric equivalent, and kcals per minute for that exercise bout. Now we're going to calculate power output, which is equal to our speed multiplied by our resistance, multiplied by change in time, which is 1 in this case, multiplied by 6, which is the distance of that flywheel on the Monarch. To calculate energy output, we're taking this and dividing it by 426.8 to gain kcals per minute. To determine gross mechanical efficiency as a percent, we're going to take our 1.48 and divide it by the kcals that we expended for this activity. So this is gross, it includes everything. To determine net, we do essentially the same thing, but now this time we have to subtract the kcals expended during our resting steady state. So we're going to do the energy output divided by kcals per minute of the exercise minus the kcals per minute of the resting steady state. And to be able to easily copy and paste this, we need to hold this column. So we're going to put that money sign before the 12, but not the B, to hold the row, but not the column. And then we're going to do the same thing for true mechanical efficiency. This time we're going to subtract that steady state during resting and the steady state of freewheeling as well. So energy output divided by parenthesis the kcals per minute minus resting steady state minus freewheeling steady state. And we need to go put that money sign before both of those numbers. Okay, drag that and copy and paste. By using that money sign, we're able to do this. If I go in and double click this, it should show that I'm still subtracting that resting steady state kcal. Same thing, it's pulling from the right boxes to get that information. So now we've completed all the calculations. If we go into answers, this is just going to be a little easier to complete the homework. So for number 1, you're making 2 tables, one for each part of the data collection. So our first part and our second part. And you're looking at the gross, net, and true mechanical efficiency during each. So that's this data for each subject. Then for number 2, we're going to graph the efficiency and increased workload, which is part 1. So we're just going to highlight that, go in, and change everything that we need to change. We don't go below 0.25. And here we don't go below 1.25. Then you'd go in and you'd insert a little comment bar or text to just let us know that this is at 1.5 kp and this is at 3 kp, because our axes doesn't let us know that information, because this is going to be our true mechanical and this is our energy output. So we don't know which workloads, so you either need to go in and insert a little text box that lets us know this is at 1.5 kp and this is at 3, or you need to include it in your figure description. So then you do the same thing for the other individual, and then we need to graph the efficiency and optimal speed. This is actually going to select that, and we'll create this graph. Again, you're just going to go in, do the exact same stuff. We have speed on the bottom, net efficiency on the top. You'll do this for each subject to complete the second or the third question for the homework. And that is how you complete the Excel for this portion.